In this video, we'll be taking a look at the process framework, umbrella activities, and process flow. This process framework guides the development of software projects and outlines the technical methods applied at each step, the work products produced, and helps us manage change and ensure quality. This software process framework is a structured approach to software development that outlines the steps, tasks, and activities involved in creating software. Following such a framework ensures a systematic and efficient approach that guides project planning, reduces risk, and aids in quality assurance. So you can sort of think of this as a plan or a map that outlines what you need to do and when you need to do it while you're developing software. The process framework is comprised of a small number of framework activities, such as communication, planning, construction, and deployment. These activities are typically completed in some set order or cycle. While each software project and development team may be quite different, these framework activities should be applicable to all software projects, no matter the size or how many people you have on the team. You can think of the process framework as a hierarchy, with each level being a collection of more detailed items. At the top, we have a process, which encompasses all activities, actions, and tasks that will be performed when some work product is to be created. Under process, we have the framework activities. Each activity strives to achieve a broad objective, such as communicating with stakeholders and end users, and it's going to be applied regardless of the application domain, size, or complexity of your project. These tend to be fairly generic and define an overall activity that's going to be completed at some given time, such as planning or construction, with more details being filled in by the actions required by each activity. Each activity is comprised of actions. The actions encompass a set of tasks that result in producing a major work product. So for example, if our activity was modeling, one of the actions in that activity might be creating the architectural design of our software. And then one of the tasks in that might be creating an architectural model. So speaking of tasks, they are the lowest level of the hierarchy, and they're also the most detailed. Each task focuses on a small but well-defined objective. For example, conducting a specific unit test that produces a tangible outcome or work product. So one thing to note here is that as we move from the top of the hierarchy to the bottom, items become more specific and concrete with more tangible outcomes. Activities are general and applicable to all software projects, whereas tasks need to be customized for each project, and they are far more specific. The idea here is that we have a process that's going to define a few generic activities that will be applicable to everything we do. Then when we come to a specific project, we have to fill in the details by filling in the actions and tasks. Now you might be wondering, well, what are the activities that are going to be generic to all our projects? Well, there are 5 key activities that are applicable to all software projects. And depending on the process you're using, these framework activities may be given slightly different names, but they generally fall into one of the 5 key activities listed here, which are communication, planning, modeling, construction, and deployment. Now, bringing this back to the process framework hierarchy, this means our activities will be some form of the 5 key activities, although different process models, as we say, may give them different names, or they might sometimes group them together or split them up a little bit differently. But at their core, we'll always see these 5 key activities: communication, planning, modeling, construction, and deployment. So let's now take a closer look at each of these key activities. First is communication. This activity includes all actions related to communication and collaboration with the customer and other stakeholders. The main goal is to understand their objectives, requirements, and wants for what is going to be created. This is a critical part of the project, as these requirements you gather will become the features and functions of the software. Getting it wrong or misunderstanding a requirement can negatively impact the whole project. The key word I mentioned here was stakeholder. So what's a stakeholder? Well, a stakeholder is anyone who has a stake in the successful outcome of the project. So this is not just going to be the end users, but it can include other businesses, managers, other departments, support people, and so on. And the stake is not always a financial one. It can be any interest in the success of the project. For example, if you're creating a new inventory management system, the employees who use that system to take inventory have a stake in the project in that they want it to be a usable system that's going to make their jobs easier. Suppliers for the business may also have a stake in that they want to restock orders placed in a certain way. And management may want the project to be completed in budget, on time, and result in a more efficient inventory system, which could save them money. So not all of these stakes are financial. Some of them can be related to other things like usability, compatibility, and a whole wide range of other things. All of these would be considered stakeholders, though. So the next key activity is planning. During the planning activity, technical tasks to be conducted are decided on. Risks are assessed, and resources are allocated, and the work products to be delivered are defined and their delivery date scheduled. The overall goal is to create a plan or a map that's going to guide the team and reduce possible risks or issues that can occur. Proper planning can also help give us an accurate idea of the timeline for the project and the costs that are going to be involved. Next is modeling. The goal of the modeling activity is to better understand the problem and how we're going to solve it. During this activity, a model of the software's requirements that were gathered during communication is created and it's verified with stakeholders. Once the requirements model is completed, design work can begin and a design is created that's going to achieve all the stated requirements, at least all the ones that we negotiate with those stakeholders and are feasible to include. After a design has been created, the next step is construction. This is an activity where code is created and testing is completed to uncover any errors in the code. The last activity is deployment. During deployment, the software is delivered to the customer who evaluates the product and provides feedback. If the software is deemed acceptable, it's put into use and the product enters the maintenance phase. If the product fails this evaluation, some negotiation with stakeholders will be required to correct the defects and determine what work products will need to be redone. It's important to note here that these activities are not necessarily done only once. They're also not necessarily done in this specific order. They often have to be completed in a cycle, over and over again, until the project is completed. So a process like this should define not only what activities are involved, but also the process flow. And this process flow defines the order you complete the activities in, how the work flows between them, and when activities are scheduled to be completed. So what we're now going to do is take a look at a few process flows. So there are many different possible process flows. The most basic would be a linear process flow, where activities are simply done one after another, starting with communication and ending in deployment. While this might work for a simple and well-defined project, it lacks feedback between the activities, and there's no easy way to go back to a previous activity if rework is needed. Also, since communication is only conducted at the start, it tends to lack stakeholder feedback during the planning, modeling, and construction phase, which can be a big deal because we want stakeholders involved throughout the project to better understand the requirements, and if change is needed, we need to adapt to that. So a better flow is the iterative process flow, which repeats one or more activities before proceeding to the next activity. For example, in the flow shown here, there is a loop back after planning to touch base with stakeholders again before moving on to modeling. It also has an iterative process for modeling where the modeling activity is repeated multiple times with a new iteration of the model being completed until it is perfected and the team moves on to construction. An important note here is that this is just one example of an iterative process flow. The other iterative flows may repeat different actions or different activities at different times. Another common flow is the evolutionary process flow, which is frequently used in agile processes, and that's something we're going to be talking about in future videos. Here the activities are completed in a circular manner, where a prototype or software increment is created each time the circuit is completed. This leads to a more completed version of the software being created each time. The last flow that we'll look at is parallel process flow. In this flow, one or more activities are completed in parallel with other activities. In the example shown here, planning and modeling are completed at the same time. Again, this is just one example of a parallel flow. Other parallel flows may have other activities or parts of activities done simultaneously. Now, in addition to these framework activities, the process is also complemented by a number of umbrella activities. Unlike framework activities, which occur at a particular point of time and in a particular order or within a particular flow during the project, umbrella activities are conducted throughout the whole software project. So throughout the whole project, you're going to be doing all of these. These activities tend to be focused on project management, controlling progress, quality assurance, and change and risk management. So I do have some of these umbrella activities that are typical listed here. There are probably many more that you can think of, and we're going to go through some of them quickly, but we will go in more depth later in the course in a few of these as they come up. So the first one we have listed here is software project tracking and control. And this allows the team to assess the progress against the project plan and take necessary actions to maintain the project schedule. This is often aided by project management tools such as issue trackers like Jira and a Kanban board. And that's something we will be talking about later. Next is risk management. And this involves assessing risks that may affect the output or quality of the product and making plans to mitigate those risks. A risk in this case would be any potential problem that could impact the project. These risks tend to fall into one of 5 areas. Risks from using unknown or new unproven technologies, or 2, risks from users and functional requirements, 3, risks from applications and system architecture, 4, performance risks, and lastly, number 5, organizational risks. So you might be wondering, what is a risk? Well, an example of a risk might be something like making a mobile application for iOS, that's Apple's mobile operating system for the iPhone, but a new iPhone is coming out with a new version of iOS or significantly different specifications. This is a risk as it could introduce significant changes partway through the project if the design or code would need to be reworked for a new operating system. And many of the risks we encounter in software engineering are risks due to change, particularly change to our requirements. Next is software quality assurance, or SQA. This is the practice of monitoring all software engineering processes, methods, and work products to ensure compliance against defined standards or models. These can be organizational-wide policies and standards, or ones that are specific to a project, or they can even be compliance with appropriate regulations for the industry you're working in. Some industries have particularly strict regulations, especially domains like healthcare or anything that's safety critical. Next are technical reviews. And this is another important tool for ensuring quality, and it aims to uncover and remove any errors in work products before they make it into the next activity. These reviews take the form of peer reviews, where qualified members of the development team examine each other's work products and attempt to identify any errors or discrepancies from the project's specifications or standards being used. These work products can be any kind of technical document, source code, diagrams, test cases, or anything that's created during the project. A common example of a technical review would be a code review, in which code is reviewed by another member of the development team before being accepted into the project's codebase. So next is the measurement activity, and this consists of defining and collecting metrics related to the project, its progress, and the work products produced to date. Analyzing these metrics can give insight into the health of the product and the progress being made towards completing its goals. So when these metrics are related to code, these are called software metrics, and can include things like percentage of the code covered by unit tests, numbers of functions in a source file, or numbers of lines of code in an application, and so on. While collecting these metrics can help to give insight into the project, it is important to understand what they mean and apply them appropriately. One example of an often misused software metric would be lines of code. So it's not uncommon to hear project managers using lines of code created as some sort of positive metric which might show progress towards completing the construction of the software. They may also use this to show productivity of certain employees. However, in reality, it's not really a measure of how much progress you're making or how productive your employees are. Rather, it's a metric of how complex your software is becoming. Generally, having less lines of code while still fulfilling your requirements is a positive thing, as it means that there's less code to maintain, less code to test, and fewer areas where bugs can occur. Ideally, 0 lines, if possible, would be the best number of lines of code. Well, in reality, that's often not the case. Some of your best programmers and developers might actually be removing lines of code rather than producing them as they refactor the software. So, important thing to keep in mind here is while metrics are important, we do have to make sure that we understand them and apply them appropriately. Next up is software configuration management. And this is the process of systematically managing and controlling changes to the project. So this can be changes to the documentation, the requirements, the code, or anything else related to the software development lifecycle and your project. The overall goal being to effectively manage the impact of these changes and keep the project on track. So this could include things like build, environment, and process management, as well as defect and issue tracking. The second last umbrella activity is reusability management. And this involves defining criteria for work product reuse and creates mechanisms to ensure reusable components are going to be created during your project. So you might wonder, why is reusability so important? And why is it worth spending time on this? Well, putting in the effort into creating reusable components that can be repurposed for future projects saves time and resources and can speed up development time on the next project. It can also make maintenance far easier. If you're using these same software assets over and over again, that means there's going to be less code to maintain and bugs are easier to track down. Less code means less bugs, which means less work. The last umbrella activity that we're going to discuss is work product preparation. And this involves all those different activities and tasks required to create, store, and produce work products such as models, documents, logs, forms, lists, and others. So this is sort of everything else that goes into making these work products that isn't part of those task lists from some other activity or action. So we'll get more in depth on many of these umbrella activities in later weeks, especially work product preparation and production. But for now, we're going to move on to talking about process adaptation. So at this point, we have our framework activities, and we have our umbrella activities that we just talked about. And these tend to be applicable to most software projects. However, the actual details and tasks that we have to complete for each activity are defined by the actions and tasks. So what we've only talked about so far are activities that are common to all projects, things like communication, planning, modeling, construction, and deployment, as well as those umbrella activities. So when it comes to actually starting to tailor this or adapting it to our current project, we need to fill in the information for the actions and tasks. And these should not be rigidly defined, as each software project and team is going to be different. So a process for one project might be significantly different than a process adopted for another project. These actions and tasks and the process flow that we use between them should be tailored to the current situation and the needs of our team. The processes we're going to discuss in this course aren't meant to be unbreakable rules, but rather guidelines or a starting point to create a process that meets the needs of your project and your team. So these processes are meant to be flexible and adaptable. So how do we start defining activities for our process? As you may recall, an activity is a set of actions that must be completed during the activity. So we must ask what actions are appropriate for each framework activity given our problem, team, resources, and stakeholders. Let's now take a look at an example. And in this example, let's say we're working on a rather simple project, a small website being created for a single stakeholder by a one-man team, which is just us. For such a simple project, the communication activity might consist of only one action, which is placing a call to that stakeholder. So recall that an action itself is comprised of a task set. So in this case, that task set would be make contact with the stakeholder via telephone, discuss the requirements and develop notes, organize notes into a brief written statement of requirements, and email requirements to the stakeholder for review. Simple project means that we're going to have a simple number of actions and a small number of tasks in each action. So let's see how this fits in with our process framework. So in this case, we're saying that our one action under communication is call the stakeholder. And that one action is only going to have a few tasks: make content, discuss requirements, organize notes, and email requirements. But we're not done here. We'd also have to go along and define the other actions for these framework activities, and then fill in the task sets for each one. For a simple project like this, they'd also be fairly straightforward. But again, they're going to have to be tailored to that project. So when we're thinking about the tasks for each action, it's important to consider the needs of the project and the team. The task set is defined by creating several lists: a list of the tasks to be accomplished, a list of the work products to be produced, and a list of the quality assurance filters to be applied. For our example, making content and discussing requirements would be tasks to be accomplished. Creating notes and writing a statement of requirements would be the work products, and emailing requirements to stakeholders for review would be the quality assurance step we're taking to ensure the requirements developed meet the stakeholders' needs. For more complex projects, these would have to be far more complex quality assurance steps, there'd be more work products involved, and we would have a lot more requirements to deal with. So speaking of complex projects, what do we do if we are faced with a far more complex project that might have far more stakeholders and a bigger development team? Let's take a look at a real-world example related to Western. So several years ago, Western switched from Sakai, our e-learning management system at the time, to Brightspace. Now this choice was not made arbitrarily. Rather, Western followed a process that included communication with stakeholders to determine their needs in a learning management system. We also call that an LMS for short. This action would likely be described as requirements gathering. And requirements gathering is a common action in the communication activity where you go out and you gather requirements from different stakeholders involved in the project. However, this is not as easy as it may sound, especially in a place as big as Western. Western has many different stakeholder groups that could have been impacted by this change. Before we could even start approaching stakeholders, we would need to first identify the stakeholder groups that could be impacted by this change. A first task in the requirements gathering activity might then simply be sitting down and brainstorming a list of possible stakeholder groups that we're going to need to contact. So let's give this a try. What I'd like you to do is take 3 minutes and try to come up with a list of any stakeholders at Western that could be impacted by changing our learning management system. So remember that a stakeholder is any person, group, or organization that can affect or is affected by or has a legitimate interest in a software system and its requirements. And this isn't limited to a financial interest. It can be groups that are impacted in any way. So thinking about Western's learning management system, right now that's Brightspace, who would be the stakeholders involved in that? I'll now put up a 3-minute timer, try to brainstorm some possible stakeholders. Feel free to pause the video if you need more time. And then after those 3 minutes, we'll take up the list. Okay, it's been 3 minutes. Get a copy of your list and see how it compares to the one that I'm going to show now, and we'll take a look at some possible stakeholders. Of course, an obvious one would be faculty and students. Both are the primary end users of the learning management system, and they definitely have an interest in it functioning correctly and being easy to use. And this is even if they don't have some sort of financial interest in its success. You're not going to be very happy as a student if the learning management system is completely unusable or impossible to find what you're looking for. So some other groups that would be included would be teaching assistants and academic staff, such as grade admins, program coordinators, and everyone else. Both of these groups require access to the LMS and interact with it directly. Unions that represent these members would also be impacted, so we would also include them as stakeholders. They're probably going to have a say in how this works in case it affects any collective agreements. WTS, that's Western's Technology Services, will also have to maintain and support the LMS, so they're definitely going to have an interest in it. Other departments on campus, such as Accessible Education, Western Libraries, Office of the Register, and the Center for Teaching and Learning, would also have their own needs and priorities for the LMS. Educational tool vendors, such as Gradescope, iClicker, VoiceThread, and many others, would also have to be involved even though they're external to the university, as their products are going to have to integrate and communicate with the learning management software. There are likely going to be many more stakeholders than this as well. And you probably have come up with some that I haven't listed. The key here is that they are all impacted by the software in some way and have unique requirements that we're going to want to know about when we're planning out our software. So far, we've discussed a requirements gathering action, and in that action, a first task involving generating a list of stakeholders. But what other tasks might be part of this action? What else would we need to do to gather requirements from various stakeholder groups? Well, unlike that simple example that we saw before of developing a website with only one stakeholder that we could call on the phone, this case is more complex. There's a large number of stakeholder groups, and each group may have thousands of members. We can't simply call them all up on the phone or even have them all in one place for a meeting. So due to the number of stakeholders, we will have to take a different approach. So one possible task could be sending out surveys to members of the different stakeholder groups about desired features, as well as to gauge their interest in participating further in the process. A next step on that could be inviting select stakeholders from each group to informal meetings to gather further information about required features and functions. These types of meetings are often called listening sessions, and they act as an open forum where thoughts, feedback, and concerns can be shared. From these surveys and meetings, a list of features and functions mentioned should be compiled, and then negotiated to build a list of final requirements. A last task could then be prioritizing requirements and noting any areas of uncertainty that could pose potential risks to the project. If you're interested in learning more about the OWL migration project that Western undertook, Western still has a site that documents the current progress of the project, as well as some of the steps that were taken in regards to community engagement. The URL for that is owlmigration.uwo.ca. And that's all I have for you in this video. In our next video, we're going to be taking a look at some common process models that make use of the process framework we just saw and put together all of those different parts, those framework activities, and a process flow to give us some process models that are used in real life. Thank you for watching, and have a great day.